Okay, so good afternoon, everybody. So I think we can start now. I just want to make sure you received my emails yesterday and you understood them. Okay, number one, we're not going to have labs anymore. Okay, for test 2, I'm going to give you like a small project. Maybe I'm going to post it today or tomorrow, and then I'm going to give you a week to finish it. And on Thursday, on next week, during the lab session, you are going to demo your test 2, right? You are going to, it's like you are going to demo it like a small project. Is that okay? Any questions do you have? Yes. For a group, if you're in a group, yeah, so for this, okay, this is, I'm gonna grade it like a test, but it's more like a project. You know what I'm saying? So that means if both of you need to do one time, okay, and you need to do it like a project, okay? You know what I'm saying? Yeah. I'm gonna grade it like a test, but it's gonna be like a project. If two persons work together, you need to do one time. Okay, so I think so what I did last time, guys, I explained interrupts. I explained to 2 types of interrupts: RTI, IRQ, and RTI. Okay. Also, I explained one example here. We have just a number of examples here. But as I told you, I'm going to switch between chapter 3 and chapter 4 because they are somehow related, as you will see today. What do you mean by related? I think I made it clear, and you should understand very well, guys. Okay. Any program, you should have tasks, task 1, task 2, task 3, task 4, and so on, tasks. And then you need to decide. Main program, you can put 1 task in the main program. Every interrupt, you can put 1 task. You understand what I'm saying? That is why you can see, last time I explained the flashing, how to do flashing. And flashing was done, but I did it in RTI. In chapter 3, I also did flashing, but I did it in the main program, right? Same thing you will see today. There are several things in chapter 3. I'm going to repeat same in chapter 4. But in chapter 3, I put it in the main program. In chapter 4, I put it in interrupts. That's why, okay. So now I'm gonna go back to chapter 3 for today. I'm gonna see what I left here. The first thing I left, I wanna explain is the push buttons, as you see here. I'm gonna explain them, okay. Okay. As you see here, guys, on this on this board, we have 4 push buttons, as you see here, okay? And we have 8 switches. You should understand how a switch is different from push button, okay? It's easy, you should understand. In case of a switch, so for example, if you open the switch, just open it, it's gonna continue this way all the time, right? If you close it, it's gonna continue closed all the time. That's a switch, right? This is when you turn the light on and off. That's okay. However, in your home, you have the bell when you ring the bell. Okay, this is the push button. The idea of the push button is we have like a spring here. There is a spring here, so that when you press, you are gonna connect. You are gonna make connection. So when you press, you are gonna make a connection this way. However, once you release, it's gonna open again. So here once you connect, it's gonna continue connecting forever until you change it. But here, no, this is automatically because it has a spring. That's why every time I press, it's gonna make connection, and then once you release, it's gonna disconnect. Okay. So now we have 4 of them, and we have 8 switches. As I already explained the switches. So today I'm gonna focus on the push buttons. Okay. The way they made it here, Again, as I explained before, this board is using for education. That is why they put too many things here on the board. So the way they made it, these 4 switches are connected to BH0, BH1, 2, 3, 4. So these 4 switches are connected to BH0 to BH4. Okay, same thing, these 4 switches also connected to the same pins. What again? Why they did it? Again, they did it because this is a board for education. They want to do too many things. In Capstone, when you do your own project, you can connect either switch or push button. That means BH0 for each, from BH0 to BH3, I'm sorry, I think 3, because they are total, they are 4. BH0 to BH3, every pin here, we have a switch. We have a switch and also we have a push button for every one of them. And you have to use only one at a time. So you cannot use both of them. No, you have to use only one of them at a time. Okay. So I'm going to elaborate more. Okay. How can you program it, how it works, how it is different, how it is similar to the switch. Okay. It's very easy topic. I just deleted because I needed to teach what we need for the lab first. Okay. Okay, so number 1, as you see how it is connected, guys. So for every for every pin here, guys, as I explained before, we have the 5 volt. Also here we have a switch this way. This is the switch. Now I'm going to explain. Also we have a push button this way. Is that okay? This is only for BH0 to BH0 to BH3. So both of them are connected. Okay. What is very serious here? Very, very serious. And we had a lot of mistakes in the past because of it. I told you, you have to use one of them. Why you have to use one of them? Simply because when you connect this one and you press this one, you don't know where the 0 is coming from. So there is a 0 here and 0 is. So here you have 0. But there is no way to tell where this 0 is coming from, okay? So the way it has to be done, guys, is you have to use only one of them, okay? That is why it's very, very, very important, especially for the upcoming test as well. Very, very important. If you want to use the push button, you have to make sure the switch is open. Otherwise, if the switch is connected, so this one is 0 all the time. So if you press or don't press, you're not going to do any difference. You understand what I'm saying? So again, what I'm saying is that they put a switch and push button and connected to the same pin. This is just for education, okay? Because this port, they put too many things. So if you want to use them, you have to use only one of them. So it's very important. If you want to use the push button, you have to make sure the switch is open. Otherwise, your program is not going to work, okay? So I'm going to give you more details now. So if you look at this diagram as I'm explaining here, guys, okay? So if I want to use the switch, okay? So it should look like something like that. If the switch is connected, you can see 0. If I disconnect it, I'm gonna get 1. If you decide to disconnect the switch, you are gonna get 0. If you decide to connect, you are gonna get 1. That's it. This is for the switch. That's what I explained to you before, right? However, the story is different a little bit for the push button. In case of push button, normally it is 1. Normally it is 1. When I press the button, I'm gonna make it 0. So here at this moment you press. If you hold, here you hold. Once you release, it's gonna go up to 1 again. Is that clear? So this is how the circuit is. This is how the hardware is. Okay. If you don't do anything, 5 volt. You're gonna get 5 volt, right? So it's all the time. It's 5 volt all the time, right? Once I press the button, I'm gonna connect. I'm gonna connect the 0 here. That's why you can see I'm gonna hit 0. Right? When I hold, I'm gonna keep 0. Once I release, because of the spring, okay, it's gonna go up 1 again. Is that okay? So it's important to learn that Okay. Okay. It's important if you look at the switch, all the time you will see something like that. Every time you press, so all the time it is 1, all the time it's 1. Every time you press, you are going to make a pulse like this one. Is that okay? And this pulse, you should, if you use BH0, if you use the switch at BH0, you have to see something like that. If you use the switch at BH1, you should see something like that on BH1. That's why last time when I explained, I told you I'm going to connect, and that's also what you are going to do in the test as well. You have to connect BH0 to IRQ. Why? Because every time I press the button, I'm going to make a pulse here. And I'm going to make external wire to IRQ so that when I press the button, I'm going to make a pulse. This pulse is going to trigger interrupt. That's okay? So anyway, so let's see how can you program it? How can we use it? This push button, how it is different from what I taught before. Number one, this is port H. You have to configure port H is input as input. Okay, that's okay. All what you, and same thing like what I explained before. You have to check if you want to check if I press or not. You have to check BH0. For example, if BH0 is 1, that means you are not being you are not pressing the button, right? The button is not being pressed. You are not pressing the button. Is that okay? Once I find it is 0, that means you are pressing the button. Is that okay? Again, this is completely different from switch. In case of a switch, if it is 0, if you connect it, it is 0. If you disconnect, you can see 1, and it's gonna continue 1 until you connect it again, and so on. Okay, but this one is not like that. This one all the time it is 1 all the time, unless just in the moment you press. Okay. Yeah, so this is what I'm explaining here. After that, maybe I'm gonna also explain here how can you program it. So if you remember now I'm gonna, if you remember, I already explained before how can you use a switch here in this program. I explained how can you use a switch in order as on off for the alarm. So as I explained before, the way I did it, this is for a switch, right? The way I did it was, as you see here, guys, I'm gonna check one pin on port H. If it is 0, that means I'm gonna look to here. That means the alarm should be off. That's why I'm gonna keep looping here. I'm not gonna come here to do the alarm, to execute the alarm, the code for the alarm, right? So that means if BH0 is 0, that means system should be off. That's why I'm gonna keep looping here, and every 1 second, if I come here, if it is on, I'm gonna come here, and then every 1 second I'm gonna come here to check again. That's what I explained before. If now if the switch, if BH0 is 1, so this branch is not gonna be taken, and this time I'm gonna come this way. The branch is not gonna be taken, and I'm gonna come this way this time too, because this is, so now I have 2 positions. One position for alarm is on, other position alarm is off, right? So now this is using a switch. In case of using a switch was easy. Why it was very important? Why it was easy now? Because the switch has 2 positions. The switch has 2 positions. One position is going to give you 0 volt, and one position is going to give you 5 volt. Is that okay? Here in this example, I considered that the 0 volt means the system is off. I'm going to consider the 5 volt, the system is on. That's it. So all what I have to do, I'm going to check the pin. If the pin is 0 volt, that means okay. So I'm going to make it off, and that's exactly what I did here. So I'm going to check it. If it is 0, please keep looping here. Don't do the alarm. Is that okay? Now, if it is 5 volt, so this branch is not going to be taken. I'm going to come this way. You are okay? Just I want to check is switch in this position or that position. That's it. In case of push button, the story is different. Why? I can't do that in the push button. So what I want to do right now, guys, I want to repeat the same program I have right now. I want to repeat it again, but instead of using a switch, I want to use a push button. But the story is different. Why the story is different? Simply because for the push button, all the time it is 1. All the time it's 1. All the time it's 5 volt. Unless just the moment you press. That's it. It's just the moment you press, it's going to go to 0. You understand what I'm saying? So I can't use the same idea. I can just use and go and check if it is on and off. Because every time you go and check, you'll find most of the time it is 5 volt. So it's going to be on all the time. I don't want to do that. What I want to do is, originally it is on. Once you press the button here, I'm going to make it off. Please tell me. Here it is on and it's 5 volt. Here it is off. It's 5 volt. How I can know? So the voltage itself cannot tell me, right? But in case of a switch, I'm going to consider this one on or off, and this one is on. That's it. That's easy, right? So how can we solve this problem? We already did something similar to this one. Remember in the LCD lab, we did LCD. Remember, we defined the variable. If you want to know you are in line 1 to move to line 2, use that variable. If you want to know LC is on to make it off, use that variable. The same thing I'm going to do right now. It's the same idea. So what I'm going to do right now, guys, is in order to know if the system on or off, I'm going to use a variable. So the idea here is different from what I did here. I'm going to use a variable. For example, I'm going to call it on off, whatever you want to call it. And this variable should have 2 values, any 2 values. And I told you before, maybe I like to use 0, 0 and FF because it's easy to switch from one value to another. So I'm going to consider one value for on and one value for off. All what I'm going to do, guys, every time you press the button, okay, I'm going to complement this one. That's it. So every time you press the button, it's a push button. So I'm going to complement. So if you are 0, 0, now you should be FF. Are you FF? You have to go back to 0, 0. Is that okay? So now I'm going to repeat the same program. So you will see right now, I'm going to change this part. I'm going to remove this part. And then I'm going to write like several lines here to replace this one with several lines. So that I'm going to use the push button as on off. Is that okay, guys? Let's see how I made it. Yeah, this is the way I made it. Look here, guys. Number 1, as I told you, I define a variable here. I define a variable here, as you see. I'm going to assume 0, 0 means off. I'm going to assume FF means on. Is that okay? And now, and this is the code. This is the code to make alarm. So every 1 second, so this one is going to take 1 second, as I explained before. You have to go to the beginning. In the beginning, I have to check. Yeah, here. This is the beginning here. This is the button. I have to check. If the system is on, so I have to move this way. If the system is off, I have to come here because I should not turn the alarm on. You got what I'm saying? So it has to be in this part here. So that's what I'm going to do right now. Let's see how I made it. Look here, guys. Number 1, I'm going to say branch if set. If this one is set, if it is set, what it means? If it is 1, it means what it means? It means you are not pressing the button. So you are not pressing the button because you are not pressing the button. So that means I'm not going to change the status of on off. I don't need to change the status of on off. So I'm going to say, so here I'm going to check. If it is high, that means I'm not going to change the status. You are not pressing the button. So that's why I'm going to come to here. What I'm going to do here, guys, as you see, I'm going to check on off. I'm going to say if on off equal to 0, please go to the beginning again because the system is off. Please don't turn the alarm on. You can see it. This is in case if you don't press. Okay. If you are pressing, if you are pressing the switch. So now I'm going to come this way this time. If you press the switch. Because it is 0. Now it is not set. It's 0. So if you press, what should I do if you press? As I told you, what I have to do, I have to complement this variable. I have to complement this variable, as you see here, right? After I complement this variable, as you see here. So here, if you press the button, so I have to complement this value. Also, I have to wait until you release. So I have to wait as long as this one is 0. Otherwise, if I don't do that, because I'm afraid when you press 1 time this way, maybe I'm gonna complement here, or maybe the problem is not here, but maybe in somewhere else. So I'm gonna wait until you release to take action. However, if I take action quickly, Maybe I'm gonna come here, I find it 0, I'm gonna take another action. It's up to you. Do you want to do something like that, or what you want to do? Every time you press one time, you want to complement one time. You know what I'm saying? What I want to do every time I press one time, I have to complement one time. That's why after you press one time, so I'm gonna come here, I'm gonna complement, and then I'm gonna wait here. I'm gonna wait until you release. So once you release, I'm gonna come this way. Now I'm gonna check on off. If the system should be on, I'm gonna come this way to execute this part. If the system should be off, so I'm gonna come here to check again. Okay, guys, you got it? Number one, you should understand why this case is different from the case of a switch. That's what you should understand. You should understand why you need to use a variable here to capture the status of the system, on and off. Is that okay? And then, as you see here, I have to check if this one is high. So I'm gonna, if it is high, so I'm gonna just come here to check. If not, so now I'm gonna complement it, and then I'm gonna wait until you release. Any questions? Okay. I want to tell you something. Now I want to talk about a problem. This problem, we call it a switch bouncing. So what this means and why this one is a problem, that's what I'm going to explain now. So what bouncing means? Okay, and what is the problem of bouncing? I'm going to tell you guys. Look here. I told you I should have 0. Once I press the button, it has to be this way. Okay, once you release. So at this moment you press, at this moment you release, and at this moment you hold. This is not completely true, or this is true if you are assume the switch is idle switch. Actually, the switch is not idle. What do you mean by it's not idle? So I'm not going to get something like that. The answer is yes, you're not going to get something like that. Why? Because the switch has some mechanical parts. The switch has a spring. So when the switch tries to connect, it's not going to connect this way. No. Again, these are the two contacts. The switch is not going to connect this way. What's going to happen because of the spring? It's going to make some bouncing, and then it's going to connect. Same thing if you wanna disconnect, it's going to be the same thing. Some bouncing and connect. And because of this bouncing, I'm not going to get a signal like this one. What I'm going to get something like that. Some bouncing and then 0. Some bouncing and then it's going to settle at 1. This is how it is. This is a problem in all mechanical switches. This one is called bouncing problem in mechanical switches. And the reason for that, because we have mechanical parts, right? The spring has disconnected for some time here. Okay. Okay. So number one, it should not be something like that. It has to. So here every time you press, some bouncing are going to happen, and here you are hold. If here you release, once you release, it's gonna do some bouncing and then go up again. Is that okay? But you are telling us this is a problem. Why is this a problem? Okay, that's okay, but why is this a problem? I'm going to tell you what is a problem. The reason is, look here, guys. Imagine, as I did last time, if I connect this signal to IRQ. Listen to me. What's going to be the problem if I connect this one to IRQ? The problem is, what I want to do, I want to connect to something like that. This one, that's what I want to do. That means, and okay, so the best way to understand what I want to say, guys, you should understand, this is what I'm expecting. If I connect this one to IRQ, what's going to happen? Assuming IRQ is going to be triggered at falling edge, right? So that means I'm going to have only one interrupt. So every time I press the button, I'm going to trigger one interrupt. Is that okay? You're okay with that? Makes sense, right? Because you have only one falling edge. However, if I connect something like that to IRQ, I'm going to have multiple interrupts. It's like you pressed 3-4 times. You press one time, but I'm going to take action 4, 5, 6 times. Why? Because every falling edge here, you are going to trigger interrupt. We have another falling edge here. Okay, then go up and then another falling edge here. So you are going to trigger 3 interrupts here. Same thing here. Every falling, and so on. Is that okay? That's a problem. Okay, guys, that's what we call bouncing problem. Any questions? How can we solve this problem? I'm going to tell you how. Also, I have a very nice video. You remember last time in the IRQ what we did? Every time you press one time, we shifted the AED one time. We shifted the AED one time, right? However, now if I do it, if there is a bouncing problem, every time you press one time, you are going to shift 3, 4, 5 times. So every time you press one time, you are going to shift 3, 4, 5 times. Okay. Why? Because you have multiple here. So how can we solve it? Also, I'm going to choose a video. I want you to understand from the video. Okay, guys. So again, what I want to do, every time I press one time, I want to trigger, I want to take one action, right? I want to trigger interrupt one time. But because of the balancing, what's going to happen is look here, listen to me, guys. The problem is microprocessor is super fast. Microprocessor is super fast. Microprocessor is going to think that you pressed 3, 4 times here, and you pressed 4 times here. However, this time is around between 10 or between around 10 milliseconds, 5 to 10 milliseconds. This one between 5 to 10 milliseconds. There is no human being. There is no human being that can press 3, 4 times in 10 milliseconds. You understand what I'm saying? That's why this cannot be a valid pressing. It cannot be a valid pressing. This is something like, this is a bouncing. This is a mistake. Okay. So number one, you should now this is a conclusion, guys. Number one, please, if you don't understand any of what I'm gonna say right now, please raise your hand. Number one, you should understand what is the meaning of bouncing problem. You should understand. Every mechanical switch suffers from this problem. Okay. Number two, why this is a problem in microcontroller, why this one is going to cause a problem? Because as I told you, every pulse, you want to take one action, but actually every pulse is going to be taken like 5, 6 pulses. Is that okay? So this is another thing. And now I'm going to explain how can we fix it. Okay. So in order to fix this problem, I'm explaining here, guys, we can do it. We have some kind of hardware solutions, and we have some kind of software solution. I'm gonna focus more on the software solution, but also I'm gonna go through one of the hardware solution. So here, one of the hardware solution, guys, is like to put a capacitor here. A capacitor here. What this capacitor is gonna do? I'm gonna tell you the idea here. What's the idea? The idea here is that because when you have bouncing, this way, guys, when you have bouncing, actually what's going to happen, this one is 0. Okay, this one is 0. Okay, or in the other side here, look here. As you see here, guys, in order, if you want to go to 0, before you go to 0, you are going to have like a small spike this way. This small spike are coming from this ripple, okay, or from this bouncing here. So what's going to happen, guys? Once you come to 0 volt here, as you see here, once you come to 0 volt here, the voltage is gonna increase. Why? Because the switch is gonna so you wanna connect, but because of the bouncing, you are gonna connect to open for some time for the bouncing. So what's gonna happen here is this capacitor is gonna charge little bit during these times, small times. And because this is a small time, very small time, the voltage is not going to increase too much to be interpreted like high. So it's going to increase a little bit, but it's still low. This is the main idea. So the main idea here, guys, because as explained before, the low can be from 0 volt to 0.3, for example. Okay. So it's okay if this one increase little bit. And I am sure it is little bit. Why you are sure it is little bit? Because we don't have much time here. The capacitor is not going to charge. It's going to take for a long time. You have very short time. So what's going to happen here? For a very short time, this one is open for a very short time. So this one is going to charge. That's exactly what happened here. Okay. And then after that, it's going to connect. So this one is going to discharge. This is what happened here. Okay, guys. So anyway, this is one of the solution. Is just you have to connect a capacitor to every push button to solve this problem. Okay. Anyway, we're not gonna do that, but I want you to know that this hardware also is one of the solutions. Now, we are gonna do what we call a software solution. What is the software solution? Very simple. Look here, guys. Every time you press, number one, I'm gonna wait 20 milliseconds. This one usually between 5 and 20. Okay, maybe 20 too much, but that's okay, just to be in the safe side. So between 5 and you can try, but I did it by myself. So I tried some values until I found it's very smooth, right? So you can try different values until you find the switch is very smooth and there are no mistakes. Anyway, so what I'm gonna do here, guys, once you press, so number one, I'm gonna put this code. I'm gonna wait for 20 milliseconds just to bypass this part, okay? And then I'm gonna write this code. I'm gonna wait until you release. After that, I'm gonna wait another 20. By this way, but because of this code, every time you press one time, I'm gonna make one action. Then I'm gonna do the action after that. So this is how it is. Every time you press, I'm gonna run this part, and then this part, and then this part, and then after that, I'm gonna take action. By this way, I am sure every time you press, I'm gonna take one action. Is that okay? So number one, I'm gonna make a delay. Once you press, I'm gonna make a delay for 20 milliseconds. Number two, I'm gonna wait until you release. Number three, I'm gonna wait another 20 milliseconds. Is that okay? What I'm gonna show right now, this is the same program I explained last time using IRQ. The same program, and also again, I intentionally made it, guys. Some programs in chapter 3, I repeat them in chapter 4, okay, to understand the same task I do. I can put it in the main program, or I can put it in one of the interrupts. So this is a program I taught in chapter. This is a program I taught in chapter 3. In chapter 4. Every time you, but I did it using IRQ. Every time I press a button, okay, I interrupt IRQ. IRQ is going to shift the LED. Okay, that's what I did last time. Now I'm going to do the same thing, but I'm going to do it in the main program, not IRQ, right? So very easy. So look at how I'm going to make it. Look here, guys. This is a main for sure. Here you just do configuration for port H, port B, whatever. Okay, and then as you see here, number one, I'm going to see if you don't press. If the button is one, if here I'm going to use this switch, okay, that's okay. You can use any switch you want. So now if it is high, so I'm going to keep looping here, do nothing, right? So if you don't press, do nothing. I'm going to keep looping here. That's okay. However, if you press, if it is 0, so I'm going to come here. So if the PH3 is 0, I'm going to come here. That means you are pressing. So once you press the button, I'm going to come this way. When I come here, guys, as you see, number one, I'm going to wait. Number two, I'm going to wait until you release. Then I'm going to wait, okay, to solve the bouncing problem. After that, I'm going to take action. So what is the action? The action, as I did last time, shift the LED. That's exactly what I did last time. Shift the LED. If the LED is not 0, go to skip. Otherwise, you put 1 here. That's exactly what I did last time. Okay, guys. I want to compare between, again, still some students, I'm sure still some students did not understand the concept of interrupts very well. But I hope after I do right now, after I do a comparison between this program and between what I did last time, you can understand very well. Okay, let's see. So this is a program I'm explaining here. As you see, guys, here, I have to always to check. Always I have to check if you press or not. So always I have to check. So this is infinite loop. So I'm gonna come here and then come here, go to the beginning again. It's just infinite loop, right? Go to the, so here in every iteration, I have boolean. That's what I said before, boolean. Every time you have to check, are you pressing or not, right? This is if you put it in the main program, because the CPU has to do everything by its own, right? So CPU has to continuously check. However, if I go to the program IRQ, I didn't need to do that. Please, that's very important to understand the concept of interrupts. Okay, so if I go to here in this program, after the first one here, yeah, here in this program here, guys, So if you see the main program here, guys, nothing, I put nothing in the main. In the main program, I put nothing because this task is not in the main, it's not going to be done by the main program. This task is going to be done by IRQ. That's why I put nothing here. I just, this is the debouncing, okay, debouncing code. And this part here is, this is what I put in IRQ. If you see here, this is the same code I have just used right now, but I removed to the part I need to check. This is a mistake many students do. Many students, when they program IRQ, they are, let's write here a comment to check if you are pressing or not. Please, you should not check here if you press or not, guys. Because if you don't press the button, you are not going to be here anyway. You don't need to check. I did that. It's okay to do that in the main program. Please compare this program with the other program. And every program I'm going to teach in chapter 3, and it has an equivalent one in chapter 4. You have to compare them together to understand. So here, as you see, every iteration I have to check, are you pressing or not? Are you pressing? If you are pressing the button, so I have to shift. Otherwise, I have to keep it checking here, okay? Here in chapter 4, please, I don't need to do that. And this is the beauty of interrupters. I don't need, because if you don't press, you are not going to be here anyway. You are here because you press the button, so you don't need to check. You are here because when you press the button, you make event. You trigger interrupters. You don't need to check. You understand what I'm saying? Because, okay. So, but if I put this test in the main program, I have to check. Right? Anyway. This is just the same program, but I'm going to teach in C language. Okay, so in C language, first of all, I can do the same thing like what I did here. I explained how can you check some bits. So in C language, so you can do something like that in C language using AND, logic AND, as I explained to you before. However, to make things easier, they give us some functions. You can just use these functions. So in these functions, we have 4 functions. These functions are going to return true if you press one switch, right? So we have here 4 for down, 4 for up, right? So, and where are these switches? I'm going to tell you the first, okay, maybe I need to go back. The first to push, look here, the first to push button, that's how, if you look at the board, this is how it is named in the board. The first to push button is named switch 2. This one is named switch 3, switch 4, switch 5. This is how it is named in the board. So for every one of these switches, we have 2 functions. One function to check if it is up or if it is down, if you press or not, right? That's it. You can simply use it. That's what I'm explaining here. So here again, we have switch 2, 3, 4, 5 down. So this one is going to return true if the switch is down. This one is going to return true if the switch is up, right? So you can use this one instead of using, so you don't need to check the pins. Again, you can use the function, or you can do as we did before. You can check BH0 as we did before, right? So using logic AND, right? So this is the same program I have taught right now, but I'm going to do it in C language. So what I'm going to do in C language here, in every iteration, I'm going to check if the switch is down. If it is not down, don't do anything, because this is the body of F. So I'm going to come here, check. Are you down? No. Are you down? No. Are you down? No. Are you down? Yes. So I'm going to come here. Every time it's down, so I'm going to shift port. I'm going to shift to port B once, and then if port B is equal to 0, I'm going to make it 1, right? And then I'm going to make debouncing, the same idea of debouncing here, okay? So here, I'm going to say here, number 1, I'm going to wait 25 milliseconds or 20 milliseconds, okay? Number 2, I'm going to wait here, as long as you pressing, so I'm going to wait here. So I'm going to wait here until the switch is released. Then I'm going to come here, wait 20 milliseconds, and then come back here. Because of this code, every time you press one time, I'm going to make shift. I'm going to shift only one time. Now I'm going to show a video. In this video, I'm going to do it twice. one time with this code, another time without the code. Why? I want you to better understanding the idea of balancing. I want you to understand if I remove the debalancing here, what's gonna happen at this moment? Okay, I'm gonna come here, make a shift. At this moment, I'm gonna make another shift. At this moment, I'm gonna make a shift, and so on. So every time you come here, you are gonna make a shift. You will see it's gonna be shifted multiple times. Okay. So I'm gonna choose a video here before we continue. So the first one has debalancing code, the debalancing code. So you should not see any problem now. Look. So every time no, sorry, this is. Yeah, shifting LED by pushing. Yeah, this one. Look here, guys. Every time I'm gonna press the button, look here. Every time I press the push button, you will see. Look, it's working very smoothly. Every time I push one time, it's gonna be shifted one time. Okay. So I don't have debalancing problem here. I don't have debalancing problem. Right now, I'm gonna remove the debalancing code. You will see what's gonna happen right now. When I press one time, it's gonna be shifted 3, 4, 5 times. Because it's actually taken several times. So now I'm gonna comment. I already commented this part. You will see now. Look here, guys. When I press one time, look. When I press one more time, look. You have the program. You can do that at home. Okay. Any question, guys? Okay, great. Okay. Now let's move to the next topic I'm gonna teach today. Next topic is about 7 segments. I told you before, yeah, we have here 7 segments. So I'm gonna explain how can we program these 7 segments. So let me show you here. Where is the board here? Yeah. As you see here, guys, on the board, we have 7 segments, as you see here. I'm gonna explain today how can we program them. Okay. Yeah. Look here, guys, the idea. So number one, tell me how it is connected. Okay, very simple. As you see here, guys, we have 7 segments. This segment we call segment A, segment B, C, D, E, F, G. So we have 7 segments and 1 dot, as you see here. Anyway, that's why it's called 7 segment display. Every segment is an LED. Every segment is an LED, okay? And the way it is connected is connected this way, okay? So for example, this is an LED, and so on, an LED this way, okay? All the cathodes are connected together, okay? And all of them are connected to one PP0. We have 4, right? So one of them is connected to PP0, PP1, PP2, and PP3, okay? To enable or disable. Remember, the LEDs, it was exactly everything like this one, but here it was BG1. Exactly simple, okay? So this LED is in a segment A, segment B, and so on. And these ones here are connected to port B. Very simple. So this is how it is connected, right? So number one, exactly same thing. Similar to what I did before for LEDs, the same thing. If you want to use 7 segment, you have to make sure you have to put 0 here in PP0, in its enable bit. That's exactly what I did for BG1 when I used the LEDs. Now every 7 segment has its own enable bit. The enable bit here is PB0, PB1, PB2, PB3. This number 1. So if you want to use 1 7 segment, you have to make sure you have to put 0 here to use it. Number 2, similar to what we did before for LEDs, if you put here on this pin 5 volt, you turn this segment on. 5 volt or logic 1. If I put logic 0 or 0 volt, you turn it off. Similar to what? This is port P. And as I explained to you before, now port B, yeah. Now, as I explained to you before, we have port B. Port B connected to the LEDs we have. But the LEDs has one enable, BG1. Now also port B is connected to the 4 7 segment. Okay. And again, I said we did this way because we don't, this one is done for education and so on. So this one PB0, PB1, PB2, PB3. So whatever you put in port B should be shown on all of them if all of them are enabled, right? That is why I said before, the way usually we do it is, if you want to use the LEDs, you have to book here 0 volt. But you have to make sure here you have to put logic 1 or logic 1, logic 1, logic 1, or 5 volt to turn them off. Same thing. If you want to use 1 LED, you have to make sure you put here 0 logic, and you put here 1, 1, 1, and also you have to put here 1 to turn them off. So now we have four pins, 1 enabled for each one of them. Each one of them should be on at a time. You should not turn 2 at a time. That's okay. How can you do that? Make sure only one of them has 0 and the other ones have 1s. That okay? Now, how I can use, so now how I can use this, how I can use this 7 segment? Very easy. I'm going to tell you how. As I explained right now, guys, if I want to use 1 7 segment, okay. For example, I want to use the first 7 segment. Number one, you have to put 0 here in PB0 to enable it. That's number 1. You have to put 0 in PB0 to enable it. That's number 1. Number 2, you have, if I want to display number 0, that means all of them should be on. All of them should be on except G has to be off. To do that, this is the number I have to put in port B. So on port B, I have to put this number 1 1 1 1 1 1 0. Why? Because this one is going to make the shape of 0. It's going to turn all of them on except G. Right? So this is the code. This is the 7 segment code. This is the code you have to put in port B if you want to display 0. Same thing for anything else. So if you want to display number one, so I have to turn C and B on, and everyone else should be off. C and B. So these two should be on. Everything else should be off. That's why if you want to display 1, you have to put this code on port B. Okay, guys? Same thing if you want to do number 9. If you want to do 9, right? In case of 9, so 9, this is 9, right? So this is 9. So all of them on except E. That's exactly what I did. All of them on except E. In case of 8, all of them should be on. Okay, guys? So this is the code. So very simple, very, very simple. Listen to me. Number 1, if you want to use the 7 segment, you have to do 2 things. Number 1, you have to enable the 7 segment you want to use. That's number 1. Number 2, if you want to display any number, any digit, you have to use the code for this digit. And I explain how we came up with this code. Is that okay, guys? You have to send this one to port B. That's it. That's it. I'm going to give you an example right now. So as you see here, guys, this is how it is connected. All of them are connected to port B, as I explained. Every one of them has enable PB0, PB1, PB2, PB3, and so on. Is that okay? Any questions? Okay. I want to make something interesting right now. I'm going to make like a counter. I want to make a counter using the display. So you can see 0 for 1 second, 1 for 1 second, 2 for 1 second, 3, 4 until 9. After 9, come back to 0. So I'm going to use only one 7 segment. I want to use a counter to count. The interesting thing, and please pay attention. So it's a very important thing. What I'm going to do right now, the same program. I'm gonna touch the same program twice. One time when I put it in the main program, and another time when I put it in RTI. If you want to make timer counter like this one, I'm going to use RTI right now. Okay, so you should understand how can I do it. So let's see how we can do it. Look here, guys. So let's first start how I can do a counter, something like that, in the main program. Number one, I have to make an array or a table, whatever you want to call it. This array should have the codes, the 7-segment code, these codes. So that if I want to display number 0, I'm going to go to location 0. If I want to display number 0, I'm going to go to location 0 and get this code and send to port B. If I want to display number 1, I'm going to go to location 1, get this code, send to port B. If I want to display number 2, I have to go to location 2 and so on. If I want to go to 9 and so on. That's what I'm going to do right now. I'm going to show how I did it. Okay. So as you see here, guys, number 1, I have to, I'm going to create this table because I need it right now. Also, here, this configuration is different from what I did before. Number 1, you need to, let's first talk about direction. Yeah, direction is the same as I explained before. You have to configure port B as output, BJ output, port P is output. That's okay. This is similar to what we did before, but the other part is different. This one is different, and this one is different. Why? Because if you remember what I did before in LEDs, I had to use bit clear, because bit clear, you are going to enable LEDs. But this time I want to disable LEDs. That's why I used the bit set. So BG1 should equal 1 to disable LED. Okay. Also, if you look at the code here, I used E. E is 0111, right? In order to turn the first LED on and turn the other ones off. Okay. What happens if you forget and you turn all of them on? What's going to happen? No problem. What's going to happen? You will see the same number repeat, which just doesn't make anything. It doesn't make any sense, right? The same number repeated 4 times, right? Anyway. So this is how can you do the configuration. Now the program is here. All the time we are here, okay? All the time we're looping here. Let's see how can we do it. Number 1, as you see here, guys, I'm gonna initialize X with the beginning address. So X is here. I'm gonna point, all right? Because I'm gonna go through the array right now. So now X is here. I'm gonna take this one, send to because it's number 0. Send to port B, wait 1 second, increment X. X is 1, send to port B, wait 1 second, increment X, and so on. That's exactly what I want. So here, as you see, number 1, I'm gonna initialize X. Number 2, I'm gonna say, take the byte, take the value pointed by X, put it to port P. So here in the first iteration, I'm gonna take this one. Second iteration, I'm gonna take this one. Third iteration, I'm gonna take this one, because every iteration I'm gonna increment X. In every iteration, I'm going to increment X. Okay. So here, so in every iteration, I'm going to take one value, put it here, one value, put it here, for sure. I need to check once I come to here, once I finish this one, next time I have to come to here, right? Otherwise, it's going to continue in the memory. It's going to continue in the memory. Okay. Then once you do that, once you put a number here, you have to wait. I'm going to wait for 1 second, right? After that, I'm going to check if I already reached it to the end or not. It's set with. If you reach it to the end, so that means register X should equal to the initial value. I started from here, right? This is the initial value for register X. Every time I increment, once I increment it to here, that means the initial value plus 10. That's what I did here. So I'm going to compare register X to initial value plus 10. If it is not equal, so I'm going to come here to take next value and keep repeating. However, if it is equal, that means I finished. So I have to initialize it again to the beginning. If it is equal, I'm going to come here, and this one is going to send me to here to reinitialize it. You got what I'm saying? Yeah. So here in every iteration, I'm going to compare register X with the last value. If register X is equal to last value, so I'm going to move to this one to reinitialize it to go to the beginning again. So that after 9, I want to see 0. After 9, I want to see 0. Let me show you the program to understand better what I mean here. Okay. Let me show the video. Sorry. Counting seven. Yeah, maybe the camera is not that good, but you can see. Look here. The number 1, 2, 3, 4, 5, 6. Every 1 second I update it. 7, 8, 9. After 9 should come 0. Yes, 0, 1, 2, 3, and so on. Is that okay, guys? Okay. Any questions? Okay. Now I'm gonna teach 2 things. Number 1, I'm gonna teach how can you do the same thing using C language. Then I'm gonna teach how can you do the same thing using RTI. Right? So, and you should understand. You should understand. As I said multiple times, one task you can decide. I want to put this task in the main program, or I want to put it in one interrupt subroutine. You should understand if I put this task in RTI, I'm not gonna do this one. I'm not gonna do this one. I'm not gonna count for 1 second. Otherwise, interrupts are useless, right? I'm not gonna count. CPU is not gonna count for 1 second. External circuit will do that, and this is the purpose of using interrupts, right? You know. So let's see how can you do the same thing using C language first. So I'm gonna teach it using two approaches. Oops. I'm gonna okay. So let's see the first approach. Again, whatever, maybe there is one approach better than the other, whatever you want. I always like in programming, I always like, if there are different ways, I like to teach the different ways. Okay, but anyway. So here, what I'm going to teach right now is somehow very close to what I did right now. So I'm going to make a table. I'm going to make a table like this one, array like this one, and that's what I did. So this is the array is here. So in this array, I call it digits. So in this array, this one here should be, if I want to display 0, so I have to take the value at element 0. If you want to display 1, I have to take the value at element 1, and so on. Is that okay? And then here I'm going to use LED disable, 7 segment enable. Is that okay? And now I'm going to have infinite loop here. In every here, I'm going to have here, I'm going to loop 10 times here. For I from 0 to 9, 10 times. Okay. So here I'm going to display number from 0 to 9. In every iteration, I'm going to display number from 0 to 9. As you see here, guys, what I did in every iteration, I'm going to take the element I. So when I is equal to 0, I'm going to take this element. When I equal to 1, I'm going to take this element. When I equal to 2, I'm going to take this element, and so on. At the last iteration here, I'm going to take this one. Okay, so we have a function. This function is called segment7 on, right? And then whatever you put here is going to be placed on port B. And then you have to tell me here which display. So this one should take value of 1 or 2 or 3 or 4. 3. 0, 1, 2, 3 for the 4 displays we have. So now, so what happens here, guys, to understand it? So what here? Whatever you put here, port B should equal this value. That's exactly what should happen inside this function. So what this function is doing, whatever put here in the function is going to put it in port B. Also here, you have to tell me which one. Okay, as you see here, in the first iteration, I'm going to put this one in port B. This one is 0 all the time because I'm using only one display. All the time I'm using one display. Then every time I'm going to wait 1 second. Next time I'm going to take this one. Next time I'm going to take this one. Next time I'm going to take this one, and so on. Is that okay, guys? Any questions? I have a much easier way. Okay. What is the much easier way? Because we have, and this is, okay, this is the beauty of, maybe you can see it good when we see it bad. For C language, you can use functions like encapsulation. You can encapsulate, you can hide everything inside one function. You may not know the details of the function, but it's gonna work, okay? So that's exactly what I'm gonna do right now. So I have so I don't even need to define this one, because this one I can define inside the function. So I have a function. This function is gonna do everything for you. This function is called segment 7 decimal. You don't need to worry. You don't need to worry about the conversion from a number to 7-segment code. You don't need to worry about that. Just give me the number and I'm going to convert by myself. That's exactly what happened. So if you look at the code, this function here, guys, is called segment 7 decimal. If I put here number 7, it's going to display 7. It's going to do the conversion internally. If you put here number 5, it's going to display 5. So just to give number, not code. Okay. So that's exactly what happens here. As if you see here, guys, if I put here 0, I'm going to display 0. In the second iteration, I'm going to put 1 to display 1, 2, and so on. Any questions? Any question, guys? Okay, great. Now I'm gonna jump to chapter 4 to show you how I can do the same thing using ArchEye, right? The same thing using ArchEye. So I have the same program here. I taught it here in chapter 4 using ArchEye. Look here, guys. Number 1, I wanna change the number every 1 second. That's what I did last time. If last time when I did flashing every 1 second, right? You remember last time what I did? What I did last time was okay. What I did last time was you remember I wanna make flashing every 1 second, but I found that I cannot make interrupts every 1 second. Okay, and the maximum time I had, it was 131 millisecond. So what I did last time, I made every 8 interrupts. So every interrupt means 131 millisecond. All what I have to do in order to count for 1 second, I have to count interrupts. So every 8 interrupts, I turn it on and off. That's what I do. Same thing, I'm going to do it right now. So as you see here, guys, number 1, I'm going to configure ArchEye to make interrupts. This one here. Let me use a different color. So as you see here, so here I'm going to configure ArchEye to make interrupts every 131 millisecond. Okay, and this is the interrupt subroutine. Remember, I'm repeating what I said last time. You have to clear the flag bit. Please don't forget this one. Please, you are gonna regret, because if your program is too long and it's not working, I don't know why it's not working. So you have to check. You have to check everything, right? Because you don't know if once you know, you solve it in no time, but you may spend long time just looking for the mistake. Anyway, so all the time it's so you have to do this one as I explained last time. Also, as I explained last time, every interrupt I have to increment a counter. And then I have to check to 8 interrupts. 8 interrupts. If it is not equal to 8, come here. So if it is 8, so okay, just leave. Come here and leave. That's what I explained last time. So every 8 interrupts, I'm gonna do this part. So this part will be done every 8 interrupts. 8 interrupts. Why 8 interrupts? Because 8 interrupts are actually 1 second. 1 second. I wanna change the number every 1 second. What if I want to change the number every half a second? Very easy. Just instead of 8, put 4 here. That's it. If you want to make it every quarter, just put here 2. And I think that's what you need to do in the test as well, right? Same thing. If you want to do it, you can put 16 here. If you want to do it every 2 seconds. Anyway, you will see. So every second, I'm going to execute this part for every second, right? What should I do here every second in this part? Number 1, I have to clear the counter. I have to clear the counter to count for another 8. I have to clear the counter to count for another 8. And then what I'm going to do right now, guys, is this is the main idea. Look here. I have to use this one. I have to use this one in the first interrupt. A first interrupt means after 8 interrupts. So after 1 second, I have to use this one. In the second, after 2 seconds, I have to use this one. In the second 2, right? In third time, I have to use this one. Fourth time, I have to use this one, and so on. How I can keep track? You understand what I'm saying? So after 1 second, I have to do this one. After 2 seconds, and so on. How I can keep track of that? In order to keep track of that, I'm going to use a variable. This variable is called count. Count here. This count in the very beginning, count is equal to 0. Once I display this number, I'm going to increment the count to become 1. In next interrupt, okay, so I'm gonna display this one, increment the count to this one, and so on this way. That's exactly what I did. Look here, guys, what I did. As you see here, x. So what I'm gonna do right now, guys, I'm gonna display x plus count. Count should take a value from 0 until 9. Okay, so this is the address. If this address is hitting this one, I'm gonna take this one, put it in port B. So this time, listen to me. This is very, very serious. Listen to me. Why you changed it? If you go back to what you have just explained right now, you didn't use a variable called count. What you did right now, you just incremented x. That's exactly what I did. You can see here, guys. So what I did right now, x is here. Take this one, display, increment x, increment x, increment x, increment x. This time, I can't do that. This time, I can't do that. You cannot increment x. Why? Any answer? Why? Why this time I did it in a different way? And instead of incrementing x every time, I'm going to use a memory location count, and then I'm going to add x. Okay. So what I'm going to do right now, guys, so the reason I can do this one, I can do it this way here, guys, because as I explained to you before, the way I'm going to do it here, I'm going to fix x. X is fixed here. All the time x is here. All the time x is here. What I'm going to do, I'm going to add x plus count. Okay, so now I'm going to change the count. So if count is 0, I'm here. Count is 1, I'm here. Count is 2, I'm here. Count is 3, I'm here, because it's x plus count. I didn't increment x again because, as I explained to you before, if you increment x, the program is not going to work. Why? Because every time you increment x, the interrupt is automatically are going to put the initial value in x. Very important. So I did it this way in the main program, but I can't do this way. So see what I did right now, guys. So every time x, I'm going to initialize x with the beginning address. Then I'm gonna load count, put it in A, and then I'm gonna read the location pointed by x plus A, put it in B. So what's gonna happen? X all the time is here. X is always here. I'm gonna add count, okay, and then this should give me the address. In the first time, count is 0, that's why I'm gonna take this one. When count is 1, I'm gonna take this one. When count is 2, I'm gonna get this one. Count is 3, I'm gonna take this one, and so on. Is that okay? Please, you should understand why here I can't increment x, because as I explained to you before, in any interrupt subroutine, if you do that, x is going to take the initial value back, all right? So anyway, so I'm going to read this one, then I'm going to increment the count for next time. So I'm going to increment the count for next time, and then I'm going to see if count is equal to 10, please make it 0, because count should be 0, 1, 2, 3, 4, 5, 6 until 9. Once when I increment it and find it is 10, please become 0 again. So that after 9, I have to count 0, right? That's exactly what I did. So what I did here, after I display the location pointed by x plus count, okay, the digit at the location x plus count, so I'm gonna increment the count, and then I'm gonna check if count is equal to 10, right? If count is equal, if less than 10, do nothing. If it is equal to 10, please, you have to clear it. Any question, guys? In order to understand interrupts, please, that's why you should look at the two programs, how I made it in the main program, how I made it in interrupts. Okay. Now I'm going to move to a next, not topic, but next thing here. The next thing here, guys, I already explained how can you use 1/7 segment. Okay, what if I want to use You told us something very dangerous. Yes, it's very dangerous. What is this? I'm gonna tell you what is this. Look here. You told us all the seven segments, the 4 7 segments we have are connected to port B. That means if I put here the code for number 5 and I enable all of them, I should see 5 5 5 5. Does that make sense? Okay, if you enable all of them. But this way it's going to be useless. What if I want to multiply? What if I want to display more than 1 digit? I want to display something like 3 3 7 2 5. I want to display something like that. How I can do that if it's already all of them are connected to port B? Okay, I'm going to tell you how. In order to do that, we are going to use a technique. This technique, we use it time multiplexing. Okay, time multiplexing. So what is the idea of time multiplexing? I'm going to explain it right now. Okay. Look here, guys. That means you are telling us I can display 4 different digits this way. The answer is yes, you can. How? I'm going to tell you how. Look here, guys. The idea is that I have 4 displays. Remember, every display okay. So what I'm saying here, guys, we have four displays. Everyone has one enable, to enable or disable. One enable. That's okay. Look how I can display a number, and we have only port B. Port B. Yes. What I'm gonna do right now, guys, I'm gonna put number 3 on port B, but I'm gonna enable only this one. I'm gonna disable these ones. Okay. So number 1, I'm gonna put the code needed for the code of number 3. I'm gonna put it in port B. Number 1, I'm gonna enable this one by putting 0. I'm gonna disable the other ones by putting 1s. So now you can see number 3. Then I'm gonna put some delay. Then I'm gonna now put number 7 on port B, but this time I'm gonna enable this one. So I'm gonna put here's a 0, here's a 1. Is that okay? Then I'm gonna make little bit delay. Then I'm gonna display I'm gonna put number 2 here, but this time I have to enable this one. Finally, I'm gonna also make some delay here as well. Then I'm gonna put here number 5, but this time I'm gonna enable this one. Then I will repeat again. Actually, only one of them is on at a time. That's for sure. And we must do that because all of them are connected to port B, right? So only one of them on at a time. However, you will see the number very stable. Okay? Why? Because you do it, if you do it very quickly. If you do it very quickly, you will see the number stable. Is that okay? If it is slow, if you do it slow, you are going to see flicker. So you'll see on off, you will see some kind of flicker if you do it slow, right? That's what technique we call it time multiplex. Any question? You understand the idea? That's what we are going to do right now. I'm going to explain how can we do it. That's what we are going to do right now. Let me tell you something very important now. Two things can happen, and you should know if they happen. You should know the reason for that. 2 things. Number 1, the numbers may be dim. If the numbers you are seeing here are dim, what it means? It means you don't have enough delay here. That's why I have a delay here. I have a delay because I can't just put 5 volts, just remove quickly. No, I have to keep the 5 volts for some time so that the 7 segment can reach to the maximum brightness, to be bright, to see it, right? So that means if you do it and you find it's dim, simply that means it is dim because you have to increase this delay. Is that okay? And that's why you have delay. If you remove this delay, it's going to be dim. I think you have to keep it at least 5 milliseconds. If you make it short and 5 milliseconds, you are going to see it's going to be dim. This is the first problem you may face. The second problem you may face, you can see flicker. Flicker means on off. So I'm not going to be stable number. It's not going to become a stable number. It's going to be like flicker, on off, on off. Okay. If there is a flicker, you should understand the reason for this flicker is because this delay is too long. So what I'm saying now, if this delay is too short, dim. If this delay too long, flicker. So it has to be reasonable delay. What do you mean by reasonable? You can try, but when I did it, between maybe 5 milliseconds was okay, 10 milliseconds I think was okay as well, something like that. Okay, guys. More importantly, listen to me. So also, this delay, when I can do the same thing using RTI, and this time, this delay, RTI is going to make this delay. So here, this is the delay between every interrupt. This is the delay here, right? So that means if you are using RTI and you see flicker, that means the timeout is too big. You have to reduce it. If you are using RTI and it's dim, that means the timeout is too short. So the delay here is going to be created by the timeout when you do RTI. Okay? Any question? So you understand the idea of time multiplexing? Tell me this one on, everyone is off, this one is on, this one is on, and then do it quickly. And the trick is you are going to see it very stable. Okay, guys? But last thing, just one minute. Last thing I want to say quickly. Why you overcomplicate it? Why you complicate this way? Why you don't make it simple? Okay, I can make it simple, but how I can make simple? Okay, why it is complicated? It's complicated because I connect the 4-7 segment to one port. That's why it's complicated, right? If you want to make it simple, what you have to do is that this is a microcontroller. You have to take one port to connect it to 1-7 segment. This is a port. And then you have to take another port to another 7 segment. You have to take another port to another 7 segment, and another port to another 7 segment. In this case, you don't need time multiplexing. That's true. That's terrible. That's too bad. How many ports do you have? If you are going to use 4 ports just to drive the 7 segments, okay? So you are not gonna you are gonna consume most of the ports you have. You know what I'm saying? So I'm not overcomplicated because this is a best solution. The best solution because I'm going to use only almost one port. This is the beauty of it. I'm going to use only one port, which is port B. In addition to that, I'm going to use pins. For every one of them, I'm going to use pins. PB0, PB1, PB2, PB3. This is much better than using 4 ports. You understand what I'm saying? Yes, time multiplexing is something, yes, a little bit more complicated than this one, but because it's the best option. The other option is wasting 4 ports to connect the same signal. You understand what I'm saying? That anyway, so I'm going to explain the program next time. Also, I'm going to explain how can you do it using RTI. Okay, thanks.